All right, welcome everyone. Thanks for coming. I have to be perfectly honest with you that preparing for this talk, I was a nervous wreck. It was, coming here in DC, London, it's a big deal. And I thought, how am I going to do this? A lot of people were very considerate and consoling of friends, family, letting me know, it's going to be all right, you'll be fine. You just have to break the ice. I said, tell a joke. But I'm not very funny and I don't like a laugh, so that's not going to work. So the next best solution was tell them a story. Engage with your audience. Talk to them. Have some sort of bond by, relating something. And I thought, that could just work. Tell the story. So here we go. It's a story of the very hungry caterpillar. Now, once upon a time, there was a creepy-looking sun. Look at that thing, just gazing down, those creepy eyes, gazing down onto a caterpillar that happened to be incredibly hungry. Not only hungry, but quite an intelligent caterpillar, because it knew how to solve this hunger problem. It would go on and eat food. So that's what happened. Lots of food was eaten. There was apples and pears, and this is good. And this went over 5 days. A lot of eating happened. What happened, though, on the last day of all this eating is that you can see down here, in the same sitting, one after the other, ice cream, then a pickle. Now, I've done this. Let me tell you, I'm not surprised what happens next, because it does definitely 100% result in a tummy ache. Now, again, intelligent caterpillar knew what was going on, knew how to resolve this problem, went on, ate a leaf, felt a lot better. Now, we don't have a little caterpillar anymore, and we don't have a hungry caterpillar anymore. We have, as the book tells us, a big fat caterpillar. Now, the caterpillar, through some crazy means that I don't think anyone understands, turns into a cocoon. Does anyone know how a caterpillar turns into a cocoon? No? Anyone? I did a bit of research, and what I came up with was sorcery. It's just, they end up in a cocoon, and that is fair enough. Now, at the end of the cocoon part, what I don't understand, emerges this lovely butterfly. Not only is it beautiful, but it also has upside-down wings. Yeah, the wrong way around. And that is the key. Now, the part I want to focus on really is the bit I don't understand, the sorcery bit, which is somehow we have a caterpillar and it's some form of function that turns it into a cocoon of butterfly. And I have no idea why. And we don't need to know why, right? It's just what happens. Mother Nature gives us. Now, Mother Nature has given us a function called make butterfly. And this is it. So we have make butterfly, takes a caterpillar, we get a cocoon butterfly back. And that really is what is key, is that we don't know, we don't care, we just do it. Now, it's not quite that simple, because I have seen out in the wild ugly butterflies. Look at this thing, it's all got, sticky out bits, white wings. Where is the color here? It's quite depressing for this poor butterfly. But we've seen it. We've seen the story that you can make a beautiful butterfly. So let's revisit what happened and see if it's possible, if we can work out what the trick is. So what happened is, there's a caterpillar. So a caterpillar. There was food, and so we feed our caterpillar. This happens. and then somehow it ends up in a cocoon. Now, this may look like my wife's handbag, but I assure you 100% that this is a top-of-the-line cocoon. So what happens is the caterpillar goes inside. I don't know how. It was sorcery. And there's some wriggling around like this, and lots of crazy stuff goes on. No one really knows. And it's really hard to do this standing up. And then out comes a beautiful butterfly with the upside-down wings, right? There we go. That is how you make a beautiful butterfly. What is the secret? Someone tell me, why did we not end up with one of those boring white butterflies? What I think is it's the food. It's this particular combination of food, maybe not entirely. I think maybe what happened here somewhere is what caused the upside-down wings, but I can't be sure on that. But feeding our caterpillar results in a beautiful butterfly. Now, we have a great responsibility here today. Now that we know this secret, we know how to make them, it's up to us to rid the world of the ugly white butterfly. I take out a web ad explaining to people. I'm doing this for free. I'm really quite nice. I have a web ad. I say, we've got the solution to this. We're going to feed your caterpillar. And then I create a function. And the function is to create beautiful butterflies. It takes in food, and then what it does with that food is this vast amount of food is we filter it out, we get the right kind of food out, the stuff that we care about, we feed our caterpillar, feed our caterpillar, then we make the butterfly. And what we end up with is a function down the bottom here. The definition is Butte butterfly takes a food, returns a cocoon of butterfly. Now, this is all good, and I'm going okay for a while, but I start to get complaints. People are saying, my butterfly's coming out all weird, it's not working, it's not beautiful, and so I need to get to the bottom of this. What can I do? Well, the first thing we thought was what makes a beautiful butterfly is food. So let's look at logging the food. So I throw this in the middle here. I go, all right, whatever food comes in, log it first. Then I can see, like if someone complains, did they put the right food in? Did they give it everything it needs? Am I doing something wrong? The complaints still come in. So I go, what else could it be? Maybe my butterfly's not in its cocoon for long enough. So let's log that. Log our time in cocoon. That's good. We can take care of that now. But maybe, perhaps, sometimes you just end up with a bad butterfly. So if we get a bad butterfly, let's retry the process. All right. So we have our beautiful butterfly function now, but what's wrong with it? What have we done to it because we wanted to log everything? We filled it full of this retry stuff, log food, log time in cocoon. We've made it incredibly ugly, incredibly hard to understand. And this is just the beginning, right? I think the butterfly building business is, quite complicated. And so we're only going to add more and more things to it. More logging, more error detection, more failure catching, whatever it takes, that's what we're going to put in to have a successful business. But really, the problem is that our food is up there. We do all this rubbish, and then this is here. So really, our core business stuff is now intermixed with all of this other application-agnostic stuff that really doesn't matter. So what can we do to fix that? Well, One idea is we could pull that out and have a different function, and then these other things, we just call that, right? I think that's a pretty good refactor to begin with. So let's look at that. Here we are, our let butterfly service now. It's what we pretty much started with. Let food, we take the food in, filter it, feed our caterpillar, make the butterfly. And then we have our beautiful butterfly here. Pretty much the same as before, but now instead we just call this. And so we've got our logic there. It's all pretty nice and good, except what we haven't done is we haven't reduced the complexity at all. We've got our domain logic is all out, our business logic's all sorted, but what we haven't done is reduce that complexity. Is there anything else we can do? Can we refactor this further? The answer is yes, because otherwise it would be a really short talk. If we look at the butterfly service there, its type is food, a function food that returns cocoon of butterfly. If we look at the retry function, it also takes a food and returns essentially what comes out of here, log timing cocoon, which also takes a food and returns the butterfly service. So it puts it in. So really, they also return a food of cocoon butterfly. So we've got these three things of the same types. Surely we can just compose them all together. So that's what we're going to do. The retry, log timing cocoon we're going to take care of. And we're going to refactor to this. So everything up here has stayed the same. Our food to log food has stayed the same, pretty much. But what we've done is we've pulled the log timing cocoon out, and the retry, and we're just passing butterfly service as a function into log timing cocoon and then into retry. Now, what we're not doing here is we're not doing function composition. We're not saying, all right, take the output of one function and that now goes into the input of the next, because it wouldn't work. They don't line up like that. What we're doing is we're actually passing the entire function around. So butterfly service, we just send that to log timing cocoon because it's after something of butterfly cocoon. And the same with retry. It wants a food to cocoon of butterfly, and so we just pass that in, and we're sorted. It looks good, it's a bit cleaner. The issue I have, though, is that we have these ugly braces around. And our log food up here is in the wrong place. What if we could take it from here and move it down to here? Then we end up just being able to compose everything that we're looking for. Everything that we're doing that is application agnostic, we're just composing onto the butterfly service. However, we have a bit of an issue here. The log food takes a food and logs it. That's all it really does, right? It returns food. So what we would need is for it to also meet the function type of food to cocoon butterfly. So we could change it around to do that, but I don't really want to do that. So what if we could somehow, with another function, make our log food function return this type? So what we're going to do is we're going to build it. I'm going to start here with a blank slate, and we know what we need to get out. It's here right at the bottom. We need a function that takes a food, returns a cocoon of butterfly. What we have is the beautiful butterfly service. We know we've got this. It takes our service here, S, also takes a food and cocoon butterfly. So all we need to do is if we want to, our food here, we just take a food, we log it, and then we don't care about the result. All we need to do is somehow join these up to do this. Now, we have no control, just as we had no control over the Mother Nature function to build a butterfly. We can't change this. This is written. We have no way of modifying this. So how do we get access to this food? So it turns out that the functions that are going to now use this, are going to call it, they don't care. All they want is this. They don't know, they don't need to know that they're not actually getting this. So all we need to do is create a new function that returns, that takes the food in, returns the, logs it, and then returns the original service. And so that's what we've got here. We just basically, we have a new function that starts over here with this food, it does its thing, and then it just passes that food in here and returns it. And we're sorted. Now what's fancy about this is what I'm going to name it, I think, because I'm going to call it before. We've got this function here that takes a food, returns a cocoon of butterfly, and what we've done is we've applied a function to the input. We're doing something before we call the function. And when we use it, it looks like this. So we had our food there like this, and we're changing it now to this. We're saying, okay, we've got our butterfly service. We're not going to change that. That's already written. What we want to do, though, is before we run, we've got this fancy new function, log the food. Then we can continue with the log time and the retry that we looked at before. Now, the trick here is that we don't put the input into the function. Is that we're passing the whole function around. If we apply an input, we don't get if we apply the input, we then have no way of calling before. That's done. We've lost access to that. So the reason this works is because food to cocoon of butterfly is what's called an arrow. Now, there's nothing, that's all it is. It's just an arrow is a function that returns this type. All it is a pattern. All right. So and the trick is with the pattern is that that's all it is. It's not going to solve problems that you can't solve now. It's not going to give you anything magical like that. But what it will give you is a new way of approaching that problem solving and a way of reducing the complexity and removing all the application agnostic stuff in there. All right, so what we're going to do now is we're going to talk about what makes them useful. But first, we'll look at the pattern. So we've discussed how this works, and it's an arrow, and it takes the food of cocoon butterfly. Now we can generalize this by we take it's any function that takes an A and returns a monad of B. Now, if you're not familiar with the concept of a monad, you really don't need to. If someone tells you something is a monad, then that's all you need to know. Or really, it just needs to be anything that resembles the pattern of the monad. Now, some examples are the option arrow here. We take an A, return an option of B, which is similar if you're coming from C# or some other language. It could be nullable of B. That's going to work. If you're looking at error handling, you could have the result arrow. Now, the most important one, in my opinion, or at least the most fun one, is the async arrow, which, funnily enough, is what the talk's on. Now, I'm going to just step in and we're going to talk about the butterfly service just a little more. And then we're going to move on to async. So, what I'm going to do is, we thought it was sorcery before turning a butterfly into a caterpillar. Sorry, the other way around. But I'm going to now turn it back. So we have this thing here. And this is the trick with using arrows, is that what you want to do is always never apply the caterpillar. So what did our caterpillar to cocoon butterfly take? Or well, what was it that made our service successful? It was the feeding, right? So what you don't want to do, and what I'm going to do here, is hopefully make you all awkward while I caress my caterpillar and feed it watermelon. See this? Does everyone feel a bit awkward now? Does this feel a bit wrong? The reason it feels wrong is because it is wrong. This is not what you want to do. You don't want to give your caterpillar watermelon before it's time. And that is the trick. The trick is, with arrows, to keep that pattern, is to never apply the function. Wait until right at the end and then do it. So you're keeping it as a function the whole way, and that's how we get to this beautiful composition here that we came up with before. Now, you're probably sick of the whole butterfly analogy by now. Is that agreement there? I think it is, all these laughs. More butterflies, okay. I have a feeling that someone's just trying to make me feel better. All right, so let's get rid of them. What if we took food and we renamed it? Why don't we just rename all of these things and get rid of the butterfly? Let's take food away and call it events. Let's rename to events. We're filtering food here. Let's rename this to filtering the events. We already know food and events are the same thing. Feed caterpillar. Maybe we could call this update state. That's what we're doing, right? We're changing the state of our caterpillar by giving it food. And then making the butterfly, well, that's the end bit. That's where we commit what we're doing. All right. If we go down to the bottom bit, we've sorted this one out. And really, now what our butterfly service does is it takes events in, filters the ones that it wants, updates some state, and commits it. What can we do with our beautiful butterfly thing down here? Well, we could change log food to log events. We already have made that transition with food. Log time in cocoon, what is that? What are we measuring when we log our time in cocoon? Perhaps the latency? So we log the latency. Now, it turns out that retrying making butterflies and retrying all of this event stuff, it's the same, so we leave that where it is. And what we end up with is, up the top, I'm going to name this, our butterfly service really is something that processes events. And what we've got down here runs our service. So what I'm going to do is let's clean this up a little bit. And we're going to do all of that renaming, and this is what we've got. So we process events, and then we do all of those things. Same thing that we did with the butterfly, and then we run our service. Now, I work for a company called Jet.com in the US, and we're in e-commerce, and we have hundreds of these. In fact, we have over 1,000 of them, which is another story. But we could call this essentially is a service, or some people call them microservices. But really, what we've got here and what we aim for, when I'm dealing with this sort of thing, this processing of events, is to minimize it and write our service as a function. That's what we've got. We've got a thing that processes events. We've written that. That's our business logic there, what we do with an event and how we handle it. But down here is what actually does the servicey bits. And it's just a function. Now, I'm from Australia originally. I've been living in the US for the last 2 years. And I tell you, there's a few things I really miss. And it's great being here because a lot of our culture is very similar, Australia to with the Brits. Now, Cadbury is really important. Cadbury, if you're American and you haven't had the Cadbury chocolate here, it's so much better. It's really good. But another thing I missed was QI. They don't have QI. They don't know who Stephen Fry is in America, and I miss that. Now, I got here, I arrived here, and so I'm like, I have to put QI on, and I do. And you wouldn't believe it. You call it a coincidence, but I think it's fate. One of the questions he asks are, what are the 3 things that you need to write services as functions? I kid you not, this happened. And I didn't know any of this. I'm glad I tuned in, because now I can put it in my talk and finally fill out that extra bit, that gap. And it turns out that there are 3 things, and they have all their banter and they get it wrong, but what it came down to was this. The 3 things that you need to write your service as a function are: 1, futures. You need to to work well, you need to return data from the future. Now, depending on what language you come from, you've probably got this handled, which is a big thumbs up and a tick. We don't have to worry about it. If you're in F#, you've got async. You can use all of the async operations if you're in C#, and there's lots of other languages that I'm not familiar with, but I'm told they deal with asynchronous operations as well. So for the most part, I think it's a tick. The only thing you have to worry about here is, you have to remember, is to use it. So the first thing is return data from the future. Now, the great thing about async is that it allows you to do a lot of concurrent stuff, right? And so that's what we get to next. The second thing is you have to use arrows. That's what they came up with in QI. It fits so perfectly. Have to use arrows, and look at this one here, concurrent arrows, right? So that's number 2. Now, we've spoken about arrows. You know a little bit about them. We're not going to just we're not going to just move on from arrows yet. Remember, an arrow is just a function that returns an async. But the third thing, and we've spoken about these a little bit, but we're going to give it a name, and we're going to delve into them a little more. The third thing are filters. And as we can see here from what I believe is called Instagram, I've never installed it, but you can change your photos, right? You can apply different things. You can change what it looks like without touching the original. And that is what a filter does. And that's what we're going to talk about. So let's go back a little bit. Let's go back to our process events thing here. This is our little microservice. And let's talk about what we've got here. So this process events takes events, returns, let's call it, our commit state, an async result. Takes events, async result. That's an arrow. We're good. We're using async. Tick. That's the first number thing. It's an arrow because it's that async function. And so we're good here. So here we are doing what Stephen Fry wants. We have our process events, and it's an async arrow. Now, our run service, what are we doing here? So we're using our arrow, and we're running before log events. So we're just changing things a little bit. We're doing something. We're doing our side effects here. We're logging our latency. We're doing our retry. These down here are our filters. So we've got this separation here of our arrow, we've created this, and then on top of our arrow, we've got all of our filters. Now, a key thing to remember about filters, for them to really work, is you have to be able to compose them. And we're going to look at some examples now. And so the composition really here is that we get the arrow, we pass that function into the next thing, and we pass that function into the next filter, and into the next one, and so on and so forth, to absolutely no limits until you are completely done with what you want to do. Now, it's all fine and dandy if you are interested in writing your services as functions, which is, certainly something to think about, but it demonstrates the points, but you can use it for other things. So let's not limit ourselves to that. All right, so what we're going to do now is we're going to move away from our microservice part, and we're going to look at something that is possibly a little more common, something that makes a request, a HTTP request. So we have our make request thing here, and what we're going to do is we're going to build a value called an arrow. So make request, so arrow actually ends up being, hey, it takes a request, returns an async response. I'm sure we've all seen this whenever we call some API, some service, we call something, we've got a request, and then we're promised this future value, which is our async response. Now, I don't know about you, but in these responses, it's always full of stuff I don't understand, like 200s, and I don't really know what to do with those things. So what I'm going to do is just get rid of it. What I want to do is turn this async response return value to a string. Just give me the content. That's really what I called you for. You may not want to do this, but it simplifies what we're trying to do here. So what we want to do is call our response, to string. We've got a function that grabs that response and turns it into a string. But we haven't got a response yet because all we've got here is this function. So what can we do? We need to fill in this little bit. We need to create this filter that can do that for us. So I'll make request. That's where all of our logic is that does whatever it needs to do. We don't care about that, just like the Mother Nature function to create a butterfly. We know nothing of it. We don't need to. And that's what's fun here. So we want to turn this response into a string. So what we're looking at is just changing the output there. So we're going to look at a function that can do that for us. Okay, so we start with our output. I always like to start with, hey, what do I need to get out of this? And basically, we decided at the beginning we want to return a function, takes our request, returns an async of string. And so that's it here. Now, what's our input? Well, we know that too. It's a request to async response. So it's that function. And if we look at it, we put those things side by side, it's pretty clear what we need. Well, we need a function here that turns that response into the string. Now, this is on the output, and this is why using async is so great, because we don't actually need to run the async. We can use bind or map or something that can get inside that async and turn that response into a string. And so because of that, we have a function that I'm going to call map out. Because what it does is it maps the output. So we haven't run anything, but we can actually queue up this function to do a map out, change that response. So if we now use map out here, all of a sudden our arrow has that async string. All right. Now another thing that I like to do is application agnostic, is add some form of auth token. We're making this request and we need to say, hey, I'm allowed to. So if we want to add our auth token, we have to think, what modification are we doing here? We still want to return our request async string, so what function do we need? Well, it turns out that we've sort of looked at this, but we're going to change it slightly, because what we need to do is modify our input value, which is the request. So let's try and build this function up as well. So we know we want exactly the same thing out. We're not going to change that. But we have our arrow. That's our input. We know this. And what we're doing here is we want to grab our request and modify it, add our token, and then return that request. This is familiar, I hope, because it looks the same as our before function, with the difference that it's actually returning a request this time. So we do the same thing. We can compose these things together. That's really nice. And what we end up doing is returning a function that takes our request, adds that bearer token. Now with that new request, it pushes it into this function. So we haven't had to adjust what our input value is. We haven't had needed access. We just return a new function that shows those types, that matches those types. So I'm going to call this map in because it's mapping the input. And we throw that in there, and while we do get essentially we're modifying the request, we're making some changes there, but the types are still the same. They still line up. So we have that map in satisfies that. Now, one of my favorite things I can do with arrows is because we don't apply that function, we can do whatever we like with the input and output, and it's actually possible to do things with the input and the output at exactly the same time. So let's look at log input output. So basically what I want to do here is right at the end, I want to go, all right, I want to make record that this was before I call our make request, we want to say, hey, this was our input and this was our output. So how do we do that? We know what our output is. What we want is still the request to async of string. We know what our input is. It's still exactly the same, the request of async string. That's our make request there. What we're doing here is, again, it's pretty similar. The way we create these filters is very similar to, they're all very similar, our approach, just there's some slight variation. So it's similar again to our before function, where we take our request and we log it. The difference is our function, we want to take the string as well. So we want access to the request and access to the string. And again, that's possible. We just have that, take that function in, and it's no probs. And the reason is, again, we have that monad style pattern where we can pull that string out, write a map or a bind that will log that string, or apply that function. So I'm going to call this function after. And so if we now look at what we've accomplished. We've applied after, we've made some change to our request and string, but our calling types, they don't care. Our calling functions, it's all the same. As long as it matches that type, they don't need to know what's going on behind the scenes. And I think this, to me, is what I love most about using this pattern, is that I can access the input, I can access the output, I can do things with it, I can change the input, I can change the output, and I can access them with after at exactly the same time. So let's do a little bit of revision. And the reason we're going to do a little bit of revision is because it's time for the quiz portion of the talk. So, Stephen Fry in QI told us, informed me of the three things that we need to make arrows really work. In this case, he's talking about services as functions, but it's really applicable across everything. Can anyone tell me what they are? It's okay, this isn't the quiz bit, but you warm up your voice boxes for the next bit. So I'll tell you this bit. Return a value from the future, so async. Use arrows, use that pattern, and use filters. So as a refresher, our future is our async, our arrows are the asynchronous functions that we're passing around, and our filters are the things that are application agnostic and can be composed together. So I'm going to give you a few functions, and this is where you're going to then tell me what they are. Are they a future, an arrow, or a filter? All right. So let's start out with something we've seen before. This is the how to make a butterfly function, which for everyone who was upset and wanted more butterfly references, here they are. So the make butterfly function takes a caterpillar, returns a cocoon of butterfly. What is it? A future, arrow, or filter? Arrow. Why is it an arrow? First, let's see. Yes, it's an arrow. High five. So it's an arrow. You got it right. But why is it an arrow? What's the explanation? It's because we match that definition, that pattern, where we take an input and we return something of output. And that's what this does. It's done. That's simple. That's simple. Now, here's another plug for my company, because then they say, oh, did you talk about Jet? And I go, oh, I tell them all about Jet. GetJet.com returns an async of string. What's this? Is it a future, an arrow, or a filter? It's a future. Yeah, it's a future. It just returns async. That's it. Wow. Again, I'm jumping ahead of it. Is it a future? Yes. Yes, it is. Thank you, Doc Brown there. All right, so it's a future because all it does is return that async. What if we turned it to this? GetJet.com. Is it an arrow? Yeah, it is. High five. It is an arrow. Now, it's the same thing as before, because if you're new to F#, this might be maybe less clear, but what this is doing is it's taking unit, which is sort of our nothing value, and returns an async of string. So it still meets the something to async of something pattern. And so it is indeed an arrow. Now you might think, is there any value to this as an arrow? And the answer is there's tremendous value, because this unit here is a bit annoying. There's not really anything great that we can do with it normally. We just, hey, pass in a unit and we get this async string back. But with arrows and filters, we can change that. We can do whatever we want with it. We've got the power to modify that input and make it more flexible and do what we want. Okay, so the next one, log success. It takes something that is an A to async of B and returns an A to async of B. Future, arrow, or filter? Any thought? Filter? Yes, it is a filter. And the reason it's a filter, and this is sort of the pattern to look for here, is that it takes what is essentially an arrow and it returns an arrow. So when you see that pattern, you can go, oh, hey, I can apply this to an arrow. Or you may look at something and go, oh, I'm doing some logging of success. Can I turn this into a filter and use this pattern and compose everything together? So it is indeed a filter. Now here's one for you. Jump function takes a person and a trampoline and returns an async of accident. Is this a future, an arrow, or a filter? None. That's a very wonderful observation. Now, I'm going to actually call it an arrow. And the reason I am is because if we were to partially apply this jump person, what we would end up with is a trampoline, a something to async of something, trampoline to async of accident. And so I'm going to sort of say it's an arrow because it leads into the next thing of, is this really useful? You're going to come across this all the time where you go, oh, I've got these 3 things that I want. How do I make it into, it's not an arrow because I have to partially apply everything. It's annoying. So there's 2 ways that I approach this. One is this way, which may, let's just get this out of the way because this is an arrow. Yay. And the reason it's what we've done here is essentially we've combined those 2 values, so it's a single input to our async of accident. So if you've got just a few things and you want to pass that around and modify that input, then so 1 or 2, maybe 3, you might want to consider this. Just turn that into a tuple and pass that around, and that becomes your arrow. And that's a really good option. And I use this all the time. I have filters that work on tuples, so you can access the first and second, and map first, map second. And it's lovely and it works really well. However, we've already seen an example of the other option is that especially if you've got more than one value that you want to pass around as your input, just put it in a type. We were using the request type in the last example. Put it in a type. It may sort of change the way that you approach code a little bit and the way that you pass your data, but you get the huge benefits of arrows. All right. Now, the next one. This is the last one. I'm sure you're all relieved. You're doing well. You've passed full marks. Well, if you get this one, I guess. Filter bad words. Takes words of string and async of string and then returns a string of async string. What's this one? It's a filter. Now, I'm going to call this a trick question. And the reason is that it's similar. It looks like a filter, doesn't it? And this is one thing to look at. But because what we've got here going on here is currying, we actually will really struggle to compose it. So remember, I throw this in to remember the 2 things that make filters great is that you're passing in that function, but also you need to compose them so that you can just write that long list of stuff. So you could easily refactor this one to be a filter. All right. So I'm often asked by people about debugging these things. They look crazy, there's all this composition. Can you deal with it? Now, in my experience, once I start to deal with async anyway, I find it incredibly, it starts to get the complexity, especially when you're dealing with concurrency, the complexity of debugging increases. So throwing a breakpoint in Visual Studio or your editor of choice and waiting for it to hit and then making some sense of what's going on while there's 30 other things happening at the same time is incredibly hard. So what I tend to do when I'm dealing with async is I have to do a lot of logging, or I have to write trace logs and really look at what's going on with the output of that stuff. So my answer is async's already really hard. So we're not making it any harder, not in that aspect. What we do have, though, are filters. And in my opinion, the filters and being able to add filters at any point of the flow is incredibly useful for debugging. After every change you make, every filter you apply, log the input and the output. Log what's changed. While you're figuring out what's going on, you have easy control on what happens without having to hack apart your code and the core part of your code and potentially introducing bugs there as you're adjusting things, or you end up in a state of so many log statements that you can never return. So we lose that from when we start using arrows and we start to apply filters, and debugging actually has a lot of power there. All right, so if you're interested in learning a little more, by all means come and talk to me. There's a few things that I used as inspiration for this, so you might be interested to check it out. One is by someone from Twitter, and it's called Your Server as a Function. Now in this they talk about futures, services, and filters. And it's pretty much what we've spoken about, but we've renamed services as arrows. So it's the same thing, and in this they talk about a project that they use at Twitter called Finagle, and this essentially allows you to do that, to write those services as functions. So that's interesting. Another few things is how we get the where the arrow concept comes from, and where I've read is essentially this. John Hughes has two great papers generalizing monads to arrows, and then programming with arrows is really good. But let's not forget the greatest inspiration for this talk, which is the very hungry caterpillar. So this is an arrow. It's simply just a function, takes in a value, returns an async of something. And just remember that what makes this great is that you keep it together. Don't feed your caterpillar watermelon until right at the end, then apply that function. That way, if you pass it around, you can apply all these filters. So, and then the three things that you need to remember to be successful here is futures, use the future, the async, use the arrows, that's asynchronous functions, and then apply filters. Thank you.